So are you here? Let me know when you come. Sarah, I'm waiting for you. Sarah, I'm waiting for you. Hello? Sarah, I'm still waiting for you. Sarah, if you're online, kindly indicate. I need to know. Okay, Sarah said she is online. Sarah, good evening and welcome to today's class. And how was your day? I hope your day went well. We shall be looking at indices laws of subtraction, which I believe I gave you an assignment to do at the last class, and I'm yet to get the solution from you. So let me know what your challenges were and or are, and let's see if we can solve them before we move to today's class. So I believe I gave you this to solve. Which of them was an issue to you? Kindly go through them, and you can now bring forth your complaint. Let me know which of them gave you issues. I believe this is the assignment I gave you. Yes. If it is not, please kindly indicate. So Sarah, let me know what the problem is. If you are just joining us, you are welcome to our live class on GSS2 Mathematics. We are looking at the laws of indices. At the previous class, we have looked at the additional law, and today we are looking at the subtraction law. So Sarah, let me hear you. Okay, I didn't give you an assignment. Okay, sorry for that. Sarah was not given an assignment. So we can then go ahead and begin today's class. Sarah, sorry for that mix-up. Okay, once again, you are welcome to our online classes. In today's class, we are looking at laws of indices. We shall be taking the second law, which is the indices law of subtraction. Just like I said, at the last class, we looked at the indices law of addition, which says that when you are multiplying two index numbers and their bases are equal, the law says you add their powers. We have been able to solve examples as well as exercises on that. And there was a take-home exercise, and all have been done. So today we shall be looking at the indices law of subtraction. Now, let us consider what happens when one number in index form is divided by another with the same base. Example 1. We are asked to simplify y raised to the power of 7 divided by y raised to the power of 3. We all know that y raised to the power of 7 can be expressed as y times y times y, 3, 4, 5, 6, and 7, divided by y raised to the power of 3 can be expressed as y times y times y. Now, we are to divide. 1 y at the denominator will go with 1 at the numerator. Same thing with this and with this. Now, leaving us with 1, 2, 3, 4 y raised to the power of 4. Of course, when you divide anything by 1, it gives you that 10. So you will see arrive at this. Now, note that the power in the final answer is equal to the subtraction of the powers of y raised to the power of 3 from that of y raised to the power of 7. This is the question that we should divide y raised to the power of 7 by y raised to the power of 3. And when you divide, you will observe that the answer we got, which is y raised to the power of 4, is equal to, when you subtract 3 from 4, when you subtract the powers, and it gave us y raised to the power of 4. Let's look at another. Example 2 says we should simplify y raised to the power of 10 divided by y raised to the power of 4. This can also be simplified as this is z, sorry. This can be simplified as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 to be divided by y raised to the power of 4. And y raised to the power of 4 is said to be 1, 2, 3, and 4. So when you divide these two, z will cancel this will cancel this will divide this as well as this, leaving you with 1, 2, 3, 4, 5, 6. That is to say z to the power of 6. Note also, I said that the power in the final answer is equal to the subtraction of the power of z raised to the power of 4 from that of z to the power of 10. So, z to the power of 10 divided by z to the power of 4 is equal to z raised to the power of 10 minus 4, which is z raised to the power of 6. So, in general, if you have two indices, a raised to the power of n divided by a raised to the power of n, it will be equal to a raised to the power of m minus n. That is, this is called the indices law of subtraction. If there are algebraic expressions with given coefficients, the rule says we should divide the coefficients. The base remains the same and the powers are subtracted. Now, what we are saying in essence is this. With all of this, if you have two given indices to simplify, the law says once their bases are equal, subtract their powers so that your answer becomes the base, which is same constant, raised to the power of the difference of their powers. So, if you are dealing with indices that have coefficients different from 1, which is greater than 1 or less than 1, the rule says you should as we said, if there are algebraic expressions with given coefficients, divide the coefficients. The base, that is the given letters, remains the same and the powers are subtracted. So let's see an example that we should evaluate the following by expanding, okay, the terms. No, I should be able to solve one or two examples before we go to this. But nevertheless, let's take this exercise because I've already been prepared in this order for your own understanding. We are asked to evaluate the following by expanding the terms. But before we do that, let me get feedback from you. Do you understand all I have said, Sarah, and those online? Sarah, are you there? Okay, that she does understand. So let's move ahead. So exercise 1.1, now we should evaluate the following by expanding the terms. By expanding the terms and not by the application of the laws of indices. Okay, so this now can be said to be equal to a raised to the power of 9 divided by a raised to the power of 5. This is going to give us a times 3. This is 3, 4, 5, 6, 7, 8, and 9 to be divided by a times a times a times a. This will cancel out, this will cancel, this will cancel out, and this will cancel out, leaving us with a raised to the power of 1, 2, 3, 4, 5. Okay, this is times a, 5 a number, so that this is a raised to the power of 4. So Sarah, what you will do for me now is you are going to copy out this particular exercise and you do it at your leisure while we continue with the class. So I'll advise you copy out the remaining questions and then we move ahead with the class. You have to do same as what I did in question 1. You have to do same in question 2, 3, and 4. So quickly copy this and I would like to see them in your notes. You solve them, snap and send to me. So do that now. day and welcome to today's class. Today's class is a continuation of our previous day and welcome to today's class. Sarah, are you not copying them? If you are just joining us, you are welcome. We're having a class for the JSS2 students on indices. And at the moment, there's an assignment on the board for them to solve, which they are actually solving. So you can just introduce yourself, let me know where you are streaming from, and what you think about the class. Sarah, let me know if you are done. Sarah, you should be done copying this so that we can move ahead. Sarah, are you with me? Okay. I should scroll down. Can you see it now, Sarah? I believe it's better now. Yes, there's no number 5, Sarah. It's just 4 questions, And so I believe you must have copied it. So you can then move ahead to the next exercise. So you solve and let me have them. Okay, in exercise 1.2, we are asked to evaluate the following by subtracting the indices. Okay, now we have learned how to do that in the ordinary form. In this exercise, we are to subtract it, we are to evaluate it using the law we just learned this evening. So we say that with what you have done, which is dividing the first term by the second term, that you discover that the answer you get is same as when you subtract the powers. So in essence, raised to the power of 12 divided by 7 raised to the power of 9 can be said to be equal to 7 raised to the power of 12 minus 9, and this is equal to 7 raised to the power of 12 minus 9 is 3. Please kindly note, this is 7 cubed, okay, and not 73. Let me not say something like this. This is wrong, okay? Rather, it should be 7 to power 3. B, you have 13 to power 15 divided by 13 to power 8. So long as the bases are the same, this is going to be 13 raised to the power of 15 minus 8. When you're dealing with division, take note. And this is equal to 13 to power 15 minus 8 is 7. This is your answer. So I would like you to continue from where I stopped with this two that I've done. I will expect you to do question 3, 4, 5, and 6 before we move to the next exercise. This is still on laws of subtraction. But if you have a question, you can ask. Sarah, as you solve, be dropping your answers at the comment section. Sarah, I'm still waiting for your answers. You should not take your time. What is your solution to question number 3? Let me have it. Okay. E to the power 7. That's correct. Number 4. I'm still waiting for question number 4. Number 4 is a k to the power of 7. Okay, that's correct. What about number 5? Number 5 is, she said, okay, that's correct. 12 to the power m minus n. Correct. Number 6. Number 6, 19 to the power x minus y. That is beautiful. That is beautiful, okay? So let's go ahead with the class. Next is exercise 1.3. In this exercise, we are asked to simplify the following. If you observe, you will discover that we have coefficients in this exercise. Coefficients in the sense that not just letters, but we have some numbers in front of them. We refer to that as coefficients. Okay? They are telling us the amount of x raised to the power 10 that we have and x raised to the power 4. So this is saying 27 x raised to the power of 10 divided by 9x to the power of 4. What you are to do in this case, just like we said, you are to divide the coefficients. That is 27 divided by 9 into x raised to the power of 10 divided by x raised to the power of 4, which is equal to 27 divided by 9 is 3. I have to separate them because these are the coefficients. Why I know this to be indices, okay? So as to enable me solve them better. So 27 divided by 9 is 3, and 10 raised to the power of x raised to the power of 10 divided by x raised to the power of 4. Now it's said to be x raised to the power of 10 minus 4, which is equal to 3x raised to the power of 6. I hope you understand this. So I would like you to use this method and then solve other questions on this exercise. So let's do that now. Sir, are you there? Fourteen y to the power 7. That's correct. We said number 3 is 4p to the power 4. Okay, that's correct. What about number 4? I believe you can see it now. Sarah, I'm still waiting for solution to question number 5 and 6. Sarah, what's the issue? Sarah, what's holding you back? Okay. Okay, what's the solution to question 6? Okay, 2 times 10 to the power 5. Okay, so that's correct. That's correct. Okay, so we'll end the class with this exercise. I'm going to solve them for you, and maybe I'll leave some for you to solve as assignments. Or I think I should just leave it for you to solve. Sarah, this is what you're going to do. It's the same thing as what we have done. You have to simplify the following, leaving your answers in indices form. Okay? So you have to solve 1 to 9 of them. So please kindly copy them and solve. So Sarah, I'm going to end the class at this point. I have other things that I'm going to do. So I will not be meeting with Raf today, but I'll meet with him tomorrow. So I'm going to snap the exercise 1.4 that you have to do. What you will do is give me the solution, solve it in your notes, and then send it to me on WhatsApp so that I can look at it from there. So that brings us to the end of today's class. In today's class, we have been able to look at the indices law of subtraction, coupled with exercises and examples given. So what I have to say in essence is that, in summary, is when you are asked to divide 2 or more